Hello students, today I am going to discuss with you a very important topic called free body diagram, which comes in physics of 11th class. I will say it is a central one of the central parts of physics which comes in upcoming chapters like electrostatics, magnetism. Wherever the analysis of force is going to be done, you must know the concept of free body diagram. So let's start the topic. Myself, Dr. Kaushlen Kumar Singh, and I am physics coach for JEE and NEET aspirants. So if you go by the definition, it is simply the representation of all the external forces acting on a body in a separate diagram. It's a diagram in which we show all the external forces acting on a body. Okay. See, in many problems, you will be provided with a situation. And according to the situation, you have to think of the possible forces acting on the body and draw a diagram and show the possible forces on it. So this diagram in which we show all the forces, possible forces acting on a body is called free body diagram. Okay. Let's start with a very simple example. A ball is falling freely. Let's say a ball is freely falling under gravity. Now this is a situation that a ball is freely falling. You have to think about the forces acting on the ball and show those forces on this ball. So which forces will be acting? The ball is freely falling. So there will be only one force, that is the weight of the body, under which the motion of this ball is going to happen. So if we show weight of the body downwards, weight of the body, one force which is weight of the body downwards, there is no other force. If we neglect the air drag, if there is only one force, that is weight of the body, this diagram will be called free body diagram. So before proceeding to the method of drawing free body diagram, we must know how many types of forces exist in nature. What is the definition of force? How many types of forces are existing in the nature? So basically, four types of forces, fundamental forces, are existing in nature. Four types of forces are there. One is gravitational force. Okay. Gravitational force means if we talk about in terms of the earth is a very large mass which creates gravitational field around it, and when another mass comes in this field, it experiences an attraction force towards the center of earth, and this attraction force is called the weight of the body or gravitational force acting on the body. The magnitude is generally taken as m into g, that is acceleration due to gravity. This one force is a fundamental force in nature, which is gravitational force. Okay. Second kind of force is electromagnetic force. In this category, there comes electric force, magnetic force, force acting on a charge due to electric field, force acting on a current carrying conductor due to magnetic field. These kind of forces will be discussed in the upcoming chapter. So electromagnetic force is another fundamental kind of force. Then comes strong nuclear force. Such type of forces exist in the nucleus. See, in a nucleus there are many protons, and they are bonded inside all protons are with same charge, but they are bonded in the with the help of some force. They are confined to the nucleus. Those forces are called strong nuclear forces. And another one is your weak forces. Weak forces. Weak forces are the intermolecular forces in the forces which bound two molecules, which keep two molecules intact inside a solid or liquid. Such forces are called weak forces, or simply van der Waals forces. For example, in water, the molecules of H2O are bonded with van der Waals force, hydrogen bonding. Okay, they are connected with the hydrogen bonding. That is a weak bond. Such forces are called weak forces. So here, gravitational force and electromagnetic force, these two forces are basically macroscopic kind of forces. Macroscopic, these are observed on macroscopic bodies. And nuclear force and molecular forces are microscopic nature. Microscopic bodies, they are observed on microscopic bodies, and they are observed on macroscopic bodies. So for time being, we will be not going to these forces molecular level. We will be discussing the forces acting on the macroscopic objects. Macroscopic means those objects whose dimensions are very large as compared to the dimensions of the molecules. Okay, so with significant size are called macroscopic objects. Okay, so the next thing is, yes, for drawing free body diagram, we have to think of these forces, macroscopic forces. These are macroscopic forces. One of them is field force or non-contact type force, and another is contact type force. What is non-contact type force? All those forces which are field forces. For example, gravitational force. In gravitational force, there is one body, one mass, and there is another mass, m2. In gravitational force, these two masses attract to each other. This m1 will attract to m2 and m2 will attract to m1. But for applying this attraction force, they need not to be in contact with each other. So these forces are called non-contact type forces or field forces. These forces act when a body comes under the action of its concerned field. For example, when mass comes in a gravitational field, a charge comes in a electric field, a current carrying conductor comes in a magnetic field. So these forces are called field forces, and they do not need to be make contact with each other for the application of force. Such forces are called field forces. The example of such forces is gravitational force, electrostatic force, magnetic force. These forces are called field forces. Second is contact type force. In contact type force, there are four categories. One is normal reaction. What is normal reaction? When one body comes in contact with some another body, it experiences a push force. Both bodies which make contact push each other along normal to their common surface of contact, and such forces are called normal reaction. For example, there is a table and there is a block. A block is kept on this table. If we have to draw the free body diagram of this block, we should isolate this block. Separate. Free body diagram is a separate diagram. We have to separate it from here. We apply a weight. There will be a weight or the gravitational force acting on this block. Now if you see, due to the gravitational force is a field force. Here is earth. Earth is attracting this block, and for this attraction, earth do not need to make contact with this block. Okay, the earth will pull this block, but this block is not going downward. Why? Because of this table. Because of this table. That means if block is not going downward, table must be applying some force to counterbalance this weight. Now this force N, which will be equal to mg, that we will see later on. For instance, this force is called contact reaction force. This force which is applied to this block by the table is called contact reaction force. Contact reaction force. And where there is a contact between two bodies, in most of the cases, there is, in 99% cases, there is a contact reaction force between each other. Okay, later on we will discuss it in more detail. For instance, just understand, when two bodies are in contact with each other, they push each other. Okay, the table is pushing this block, and if we draw that free body diagram of table, you will see that this block will also push the table. Okay, so these reactions are called normal. These forces are called normal reaction. Then force by string. When a body is connected with a string and string is tight, the string always pulls the body towards it. For example, a ball is hanging with the help of a string on a ceiling, and we have to draw the free body diagram of this ball. Isolate this ball or draw the ball separately. Here is earth. Earth must be attracting this ball. So there will be a gravitational force or non-contact type force, which is the weight of the body. But if you see practically, the ball will not go downward due to the string attached to it, and the string will be tightened. Why the ball is not going downward? Due to string. The string must be applying some force, which is called tension, or the force by string, to the ball in order to counterbalance this weight. So such forces are called forces by string. Simply, if in place of a string, if you had some rigid rod or a bar, that must also be doing the same thing. Okay, so the bar or rod can do the same thing, tension force, act like string. The next is a spring. Okay, spring force. If there is a spring attached to a body and the body extends the spring, you apply force such that spring is not in its natural length. L0 is the natural length, and by applying the force, the length of a spring is extended by delta x. Then spring applies a force backwards to the ball, to the block, and the magnitude of that force is k delta x. Okay, k delta x. This k delta x is called the spring force. K is the stiffness of a spring and delta x is the extension done on this spring. So these are fundamental basic forces which we have to think of while drawing the free body diagram. Okay, now we will take example and learn how to draw free body diagram with this example. Okay, so I am going to state some steps to draw the free body diagram. Step 1. There are certain steps. You have to follow these steps and you will draw the free body diagram of a body. For example, this is a situation, a ball which is hanging with the help of a string through a vertical wall, and we have to draw the free body diagram of this ball. Okay, so the first step, separate the ball or isolate the ball. See, here there are many things. There is a ball, there is a string, there is a ball. There are three things present in it. We have to think for which body we are going to draw the free body diagram. If we have to draw the free body diagram of the ball, In first step we will just separate this ball out of the system, or we will just make it free from its contact, all the contact surfaces. So the ball has been separated in step 1. Step 2, when the ball is separated, the first force that you will apply on the ball is weight or gravitational force or field force or non-contact type force. Field force or gravitational force or non-contact type force. The first force which we have to think of while drawing the free body diagram is the field force or just simply the weight of the body or gravitational force for this instant. So this is the ball, and weight always acts vertically downwards, not downwards. It always acts vertically downwards. That is the rule for weight. Then in step 3 we will apply the normal reaction. How we have to apply the normal reaction? Normal reaction will be applied as a push force acting at the point of contact along a line normal to the common surface of contact. Let's understand it. What is normal reaction? Normal reaction acts at the point of contact. First of all, it acts at the point of contact. What is point of contact? This is ball. Think whether this ball is making contact with some another body or another surface. Just walk on the outer surface of the ball and you will find that this ball is making contact with the wall at this point. So what the ball will experience? It will experience a push force, mind it, a push force. Now push force may be like this, a push force may be like this, a push force may be like this, a push force may be like this. Okay, there are number of situations, there may be a number of cases. The thing is, a push force acting at the point of contact along a line. Along which line? Along a line normal to the common surface of contact. What is common surface of contact? Look, whenever two bodies will make contact, there will be a common surface of contact. Okay, here this is a ball, this is the surface of ball, and this is surface of wall. So if you will draw a common tangent between the two surfaces, you will get a vertical line like this. This will be the common surface of contact. Now draw a line normal to this common surface of contact. This is a line normal to the or perpendicular to the common surface of contact. Normal reaction will act along this line. A push force acting along this line at the point of contact will be the normal reaction. Okay, I think it is clear. I'll repeat it once again. Normal reaction is a push force. First thing, normal reaction is a push force. It acts at the point of contact and it acts along a line normal to the common surface of contact. Okay, so this is common surface of contact. This line is perpendicular line to the common surface of contact. The normal reaction will act along this line of pushing nature. Okay, so this is normal reaction. Step 3. In step 3 we apply the normal reaction. And finally step 4. In step 4 we will apply the tension of string or spring or rod. Okay, yeah, force by, I'll write force by, force by string, spring or rod. If there is string, spring or rod connected to the body, then we will apply the force by it. Okay, so look, whether there is a, we are drawing the free body diagram of this ball, whether this ball is connected with some string, spring or rod. Yes, the ball is connected with this string. So the string will, the string will pull itself. For a string, the string will apply a pull force, pull force acting along, acting along the length of, acting along the length of string or rope. So in first step we isolated the ball, in second step we apply the weight, in third step we apply the normal reaction, and in fourth step we apply the force by string, spring or rod. Here string is connected to the ball like this, so it will experience a pull force just along, pull force acting along the length of string or rope. Let's say this force is T, that is tension in the string. So these are four steps, simple four steps in which we will draw the free body diagram of a body. Okay, in first step you have to isolate the body, in second step we have to apply the weight of the body or gravitational force of the body, in third step we have to apply the normal reaction, and in fourth step we have to apply the force by string, spring or rod. Okay, these are simple steps. Now we will take some more examples and understand the concept more. Yes, this is a situation. Again, this is a situation in which this is a ball and it is resting between two inclined surfaces and in the action of a spring. Okay, the natural length or free length of a spring is given as 1 centimeter and the stiffness of a spring is given as 10 Newton per centimeter. Let's follow those steps. First step, isolate the ball. Second step, apply the weight. There will be some weight given in the problem. The weight will be applied vertically downwards. Third step, normal reaction. Now search whether this ball is making contact with some another surface. Yes, it is making contact with this inclined surface at this point and with this inclined plane at this point. So this ball will experience normal reaction, two normal reactions. From how many are the more number of the points of contact, the more number of normal reactions the body will experience. Here there are 2 points of contact, contact point 1 and contact point 2. The body will experience 2 normal reactions. So what is the rule of normal reaction? The normal reaction acts at the point of contact. So this is a point of contact 1 and this is a point of contact 2. At the point of contact, push nature. So here the normal reaction will be of push nature and here also the normal reaction will be of push nature, and the direction will be perpendicular to the common surface of contact. So this line N1 will be, if this normal reaction is N1 and this normal reaction is N2, N1 will be acting along this line perpendicular to the common surface of contact and N2 will be acting along this line. N2 will be acting along this line. This is N2 and this is N1. Okay, these are normal reaction. Third is spring force. Fourth step is the force by spring, string, or rod. So here spring is connected with the body, so we have to apply the spring force. But the spring force may be of push nature, may be of pull nature. That will depend whether the spring is compressed or the spring is extended. So look, here the free length of a spring is 1 centimeter, and the real length is 0.5 centimeter. Okay, the spring, if a spring were to be free, it would have the length of 1 centimeter. But here the length is 0.5 centimeter. That means spring has been compressed by 0.5 centimeter. Half length of spring has been compressed. So delta x, the compression is in spring, is 1 minus 0.5, that is 0.5. So what will be the spring force? Spring force will be K delta x. Okay, K is 10 Newton per centimeter and delta x is 0.5. So 5 Newton will be the spring force, and this 5 Newton will be acting like this. Why? The spring is compressed, so it will push. If you compress the spring will push. If you extend the spring will retract or attract. Here, since the spring is compressed, then the force of this 5 Newton force will be of push nature. Okay, so in case of a spring, you have to little think whether the spring is compressed or extended, and according to the case you have to choose the direction of the spring force. Okay, next example. See, here there is a rectangular ditch of length 3 yard. Forget about the length or width, that we will discuss later on. There are two balls or two cylinders. This is cylinder A, let's say, and this is cylinder B. Cylinder, I am saying these are kept like this. If in case anyone is confused why I am saying this as a cylinder, we are looking from this side. Okay, so these are two cylinders and we have to draw the free body diagram of both the cylinders. Okay, so let's take first of all draw the FBD of cylinder A. So first step, isolate the cylinder, isolate the body. Second step, weight of the body. Weight acts vertically downwards. This is weight. Third is normal reaction, contact reaction. Count how many contact points this cylinder is making with some another cylinder or another body. There are 3 contact points, 1, 2 and 3. So this cylinder will experience a push force, 3 push forces, 3 contact forces from these 3 contact points. Okay, what will be the magnitude? We will name N1, N2 or N3. Okay, at point 1, the magnitude is N1. N1 will be calculated through some other procedure when we will solve the problems. Here we are concerned only about the free body diagram. So at point 1, the normal reaction will be along normal to the common surface of contact. This is normal line. So N1 will be acting like this. Simple. At point 2, what will be the normal to the common surface of contact? This will be normal to the common surface of contact. Common surface of contact will be horizontal, this surface, and normal will be like this. So the force N2 or the normal reaction N2 will be like this. Like this. This will be N2. Similarly, at point 3, what will be the common surface of contact? Here 2 curved surfaces are making contact. 2 cylinders are making contact. What will be the common surface of contact? Draw a common tangent to them. This will be the common surface of contact. And normal to the common surface of contact line will be like this. First of all, identify the line along which we have to apply the force. This is a line of common surface of contact. Now, along this line, this cylinder will experience a force which is of push nature. So the force will be of push nature. The force will be of push nature. This cylinder will experience a force like this. Like this. This will be the direction of N3. This will be the direction of N3. Okay? Mind it. Once you get the line, this is the line along which the force is acting. Then you have to also think that the force will be like this or the force will be like this on this surface. Okay, the force will be like this because normal reaction is always of pushing nature. Tension or force by rope is always of pull nature and normal reaction is always of push nature. So push nature will be like this. Now let's draw the free body diagram of this ball B. Free body diagram of ball B. First of all, isolate the body or make the body separate. Apply the weight. Weight will be acting vertically downwards. Then contact reactions. Count how many contacts this cylinder B is making with other surfaces. There are two contact points. One is 0.3 and one is this point. Let's say the name of this contact point is 4. So this cylinder will experience the normal reaction from 2 points because it is making 2 points of contact. How the contact reaction will be acting at this 4.4? The contact reaction will be acting like this. This is the normal to the common surface of contact. Common surface of contact will be like this and normal line will be like this. So it will experience a force N4 like this. Similarly, this cylinder B will experience a push force from cylinder A at 0.3. Now this is your body and this is cylinder B is your body. Your body means the body whose free body diagram is being drawn, and cylinder A is an external body which is pushing our body. Okay, so this cylinder will push cylinder B along this line and the force will be of pushing nature. Why along this line? Because normal reaction is always perpendicular to the common surface of contact, and common surface of contact perpendicular to the common surface of contact line will be same. So the same force N3 will be acting on cylinder B along the same line. Next step, force by friction spring string. So friction spring string is not there, so that rule will not be applied here. Okay, so these are some basic concepts, some basic thing, very basic things about free body diagram. We will learn more and more with some more illustrations and more examples in the upcoming lectures. Thank you.